Hi, this is Alex from devstories.eu. GeoDjango and PostGIS, episode 10 of 15. Radius queries are the bread and butter of location-based applications. If you write them wrong, your database calculates the exact distance to every single row in your table, forcing a massive full scan. If you write them right, it takes milliseconds. High-performance distance queries are the difference between an app that snaps and one that crashes under load. A common mistake developers make is thinking about spatial queries the same way they think about basic math. The naive approach is to calculate the precise distance from your target point to every other point in the database and then filter out anything larger than your maximum radius. You should never do this. Calculating true distances on a sphere is computationally heavy. If your query filters by calculating the distance first, the database cannot use its spatial indexes. It is forced to check every single row. To keep queries fast, you must rely on index-backed lookups. Before looking at the database lookups, you need a way to express distance clearly in your Python code. GeoDjango provides the distance object, commonly imported simply as the capital letter D. You initialize it with a unit and a value. For example, passing the argument mi equals 5 to this object creates a measurement of exactly 5 miles. You can use kilometers, meters, or even degrees. This normalizes the measurement in Python before the query ever hits the database. Consider a scenario where you are implementing a feature that finds all coffee shops within a 5-mile radius of a user's current GPS ping. You have the user location point and you want to query your coffee shop model. You could use the distance less than or equal lookup. You write a query filter where your coffee shop location field is followed by a double underscore and the word distance, an underscore and the letters LTE. You pass it a tuple containing the user point and your distance object set to 5 miles. This works. It translates to a database function that checks if the distance is less than or equal to 5 miles. But depending on your spatial backend and how your columns are set up, this lookup might still do more mathematical work than strictly necessary by calculating exact distances before doing the final comparison. Here is the key insight. You rarely need to know the exact distance to filter a radius. You just need to know if the object is inside the circle. This is where the dWithin lookup becomes essential. Instead of distance less than or equal, you append a double underscore and the word dWithin to your location field. You pass it the exact same user point and 5-mile distance object. Under the hood, this routes directly to PostGIS function stdwithin. This function is highly optimized. It does a fast bounding box check first, which perfectly utilizes your spatial indexes. It draws a rough square around your 5-mile radius and immediately discards any points outside that square without doing any complex spherical math. It only performs precise, expensive calculations for the few points that fall near the boundary of the circle inside that square. If your database table uses geography columns instead of basic geometry columns, PostGIS handles the curvature of the Earth automatically while still keeping that index usage lightning fast. The single most valuable habit in spatial programming is realizing that checking if a point lives inside a shape is always cheaper than pulling out a tape measure to calculate the exact distance between them. Thanks for spending a few minutes with me. Until next time, take it easy.